Welcome to The Explainer. Today, we're going to pull back the curtain on how a modern office network is actually built. And we're not just going to talk theory here. We are going to build one right from scratch, starting with literally just a couple of computers in an empty room.
Okay, so let's get building. I want you to picture this. We're in a brand new office, and we've got a few computers. Right now, until they can talk to each other, they're basically just expensive paperweights. So our very first job is to connect them. Let's do this piece by piece. All right, so here we are, an empty office, our first few computers. The number one challenge is just getting them connected. We can't just string a cable between them. We need some kind of central hub, a meeting point for all the data.
And that central point is this little box, a network switch. Think of it like a traffic cop for our little network. See, the old way was to use a device that just shouted out all the data to every single computer. Super inefficient, not very secure. A switch, though, it's way smarter. It actually learns where everyone is and directs traffic only where it needs to go.
So how does it get so smart? Well, it's a pretty clever and simple learning process. The first time a computer sends out any message, the switch takes a look. It reads that computer's unique hardware ID, that's its MAC address, and makes a note of which physical port it's plugged into. It builds this internal table, kind of like a little address book. So the next time a message comes in for that PC, the switch knows exactly which port to send it to, and it doesn't bother anyone else.
All right, fast forward a bit. Our little company is growing. We're hiring more people, and now we've got different teams, right? We've got HR, IT, finance, and for security reasons, we just can't have sensitive payroll data floating around in the same digital space as, regular IT traffic. We need to build some walls.
And that is where VLANs, or virtual LANs, come into play. This is so cool. They let us take one physical switch and digitally slice it up into multiple, totally separate virtual networks. It's just like putting each department on its own secure floor of a building, even though they're all plugging their computers into the very same box.
And this really shows you the why. Why go to all this trouble? Well, first, security. By creating these virtual walls, we can make sure that HR data stays inside the HR network, period. Same for finance. But it's not just about security. It also cuts way down on unnecessary network chatter, which actually speeds things up for everybody. It lets us organize our network by what people do, not just where their desk happens to be.
Now, to make all this magic happen, the switch uses two different kinds of ports. Think of an access port like a normal door to an office. It connects one single device, like your PC, to its one specific VLAN. A trunk port, though, that's more like a main highway. It's a special kind of port that's designed to carry the traffic for all the different VLANs at the same time. This is how we connect our switch to other big network devices, like a router. Okay, so we've successfully isolated all our departments. That's great for security, but we've just created a new problem. What if somebody in HR needs to get a file from a server in the IT department? Well, right now, they can't. The walls we built are maybe a little too good. And this right here is the fundamental rule of VLANs. By their very design, they are completely separate. A message sent out in the finance VLAN is never, ever heard inside the HR VLAN. We've built these incredibly secure digital floors, but we kind of forgot to install any stairs or an elevator between them.
The solution? It's called inter-VLAN routing. We need a device that can sit in the middle of all our VLANs and make smart decisions about what traffic is allowed to cross from one to another. And that device is a router. It's like the building manager who has the master key. It can grant controlled, secure access between all the different floors.
Now, a classic, really efficient way to set this up, and you'll see this all the time in networking labs, is this kind of funny-sounding method called router on a stick. Basically, we take just one physical cable from our router and plug it into a trunk port on our switch. Then, inside the router's software, we create these virtual doorways, one for each VLAN. So this single physical connection can now intelligently pass traffic between HR, IT, and finance, but only according to the security rules we set up. Pretty neat, right?
Okay, our office is up and running, but you know how it is. A new demand comes up. People want to use their laptops in meeting rooms. They want to connect their phones to the network. Our all cables everywhere setup is starting to feel a little old-fashioned. It is time to cut the cord.
And the hero device for this job is the access point, or AP for short. The easiest way to think about an AP is that it's a bridge. It plugs right into our wired network switch, and its whole job is to translate that wired signal into a wireless Wi-Fi signal that all our laptops and phones can understand and connect to.
And of course, not all Wi-Fi is the same. You've probably seen these weird numbers before, right? 802.11 something.
Well, these are the standards that the access points use, and just look at how far we've come. We've gone from megabits per second all the way up to multiple gigabits per second. It's a huge leap, and most modern networks you see today are going to be running on Wi-Fi 6 for the best possible performance.
So when you open your laptop and you see that list of Wi-Fi networks you can connect to, you're actually looking at a list of SSIDs. It's really just the public, friendly name for a wireless network. You know, like office_guest or staff_Wi-Fi. That's all it is. Now this is super important. Once we start broadcasting our network through the air, security becomes absolutely critical. For years and years, WPA2 was the standard, and it's pretty good. But today, the real gold standard is WPA3. As you can see here, it offers much tougher protection against the kinds of attacks that are common today, which makes it pretty much essential for keeping all your wireless traffic safe and private.
Okay, we've talked about all the individual pieces of the puzzle. We've got our switches, our VLANs, our router, our access points. So now let's zoom all the way out and look at the complete blueprint for the network we've just designed. Let's trace the path of the data. Everything, and I mean everything, starts with our connection to the outside world, the internet.
That internet connection comes into our building, and the first thing it hits is our router. That's our main gateway. It manages all the traffic coming in and out, and it's what lets our VLANs talk to each other.
From the router, we connect to the real heart of our internal network, the central nervous system, if you will, our switch. And finally, plugged into that switch is everything else, all of our endpoint devices. The wired PCs plug right into access ports for their specific VLANs, and our access points plug in to broadcast that Wi-Fi signal for everybody's phones and laptops.
And just to prove this isn't all smoke and mirrors, here's a little peek behind the curtain. This is what it actually looks like when a network engineer goes to configure all this stuff. They're typing these specific commands into a command line to create the VLANs, assign the ports, and set up all the routing we've been talking about.
And there you have it, a complete, secure, modern office network built from the ground up. We connected our devices, we built secure virtual walls between departments, and we cut the cord with wireless. But of course, a modern business isn't just one building, so the next challenge is even bigger. How do you take this network and securely connect it to another office on the other side of the planet? Now that is where things get really, really interesting.